So coming to you here for segment 6. What about compounds? So I goofed off with my internet connection, and hopefully we're going to see it do a little better this time around. All right, so we were working on using molar mass, gram formula mass, or I should say gram atomic mass rather, for elements and atoms, and we were looking at Avogadro's number. If you didn't do it during the slideshow or before the last segment, maybe you hopefully in between have gone and gotten that form from Student Resources, the flow chart for doing these calculations. It should help you quite a bit. All right, so when we're looking at compounds, what we have to keep in mind is that we have 1 mole of H2O molecules. That means there's going to be 2 moles of hydrogen because of that subscript, right? So for every 1 molecule, we have 2 hydrogens and 1 oxygen. So again, the mole is just a multiplier. So if I had a dozen H2Os, then I would have 24 hydrogens and 12 oxygens, right? Well, now we're just going to do it as a mole. So to find the mass of 1 mole of a compound then, what we're going to do is determine the moles of each element. Then from there, we'll figure out how much each of the element would weigh, and then we'll add those elements up. All right, so let's give it a try. What is the mass of 1 mole of CH4? So I'll go to my periodic table, and I'm going to find carbon. For 1 mole of carbon, it's going to be 12.01 grams. Now I'm going to look for hydrogen. For hydrogen, we have 4 moles, right? Because we have a subscript 4, CH4. So we're going to have 4 moles of hydrogen. Each one is at 1.01. Just a little rounding there. Don't let that confuse you. 1.01 times 4 gives me 4.04 grams. The next thing I'm going to do then is just add those up. So I'm going to take 12.01 grams from the carbon, 4.04 grams from the hydrogens, sum those up, and that gives me 16.05 grams. So that means the gram molecular mass of CH4 is 16.05. And of course, this would be the mass of 1 molecule. All right, what if it's not a molecule? Well, if it's not a molecule, then we'll use gram formula mass. Now don't let these terms confuse you. I've used gram atomic mass, gram molecular mass, and now we're seeing gram formula mass. The methods here are all the same. It doesn't matter what type of compound we have. We just have different names for each type of compound or substance. At the end of the day, in the next slide or so, I'm going to give you a very generic term called molar mass. And all of these are molar masses. So even though we're saying gram formula mass, what we're doing is finding the molar mass of an ionic compound. So again, we're going to calculate it the same way we just did for the molecule. We're going to find the gram formula mass for iron 3 oxide, Fe2O3. And so again, we're going to take the formula and we're going to multiply each one of those atoms by the mass for that atom on the periodic table. So for iron, we're going to have 55.85 grams, but we have 2 irons. We multiply that out and we get 111.70 grams. Now for the oxygen, we have 16 grams according to the periodic table, and we have 3 of them in our formula. So 3 times 16 is 48. Now I'm going to sum those two up. 111.7 plus 48 is going to give me 159.70 grams. Now again, don't let the terms fool you or confuse you. All of these are molar masses. That's going to be the generic term for the mass of 1 mole. And so that molar mass then is the generic term for gram molecular mass, gram formula mass, or gram atomic mass. All right, let's practice this a little bit. So what's the question going to look like? It's going to say calculate the molar mass. Again, a very generic term. And it's going to say for the following. And so I'm going to give you a list here. So there you go. There's a bunch of them. And if you need to, go ahead and pause the video here, give them a shot yourself, and then hit play and see how you did. All right, so for the sodium sulfide, I'm going to get my calculator out. That's going to be 78.05. The unit for these will be grams. All right. For the N2O4, it's going to be 92.02 grams. Carbon's pretty straightforward. We'll just go to our periodic table. That's going to be 12.01 grams. For calcium nitrate, there's a couple ways you can do this. You could do the nitrate first and then add the calcium, or you could do each individual one. Just make sure you carry that subscript 2 through the nitrate. So for that I've got 164.10. Now if your decimals are off by a little bit, that's probably because we're using two different periodic tables. That's not going to be a problem. Okay, so on your exam, you're going to use a specific periodic table. I'll be using the same one to make my key, and that way our answers will be the same. But if you're using a different periodic table than me right now, they could work out to be a little different, especially since I take a lot of shortcuts with hydrogens as well. So I usually use 1.01 for hydrogen. Most periodic tables will say something like 1.008. For the glucose, I've got 180. And again, because I use the 0.01 for the 1.01 for the hydrogen, I'll probably have a little different answer there, along with this next one. Look up the phosphorus real quick, just make sure I use the right number there. And there you have it. So hopefully, like I said, you're within decimal points of these answers. I could be a little off again because again I'm using one, my memory for most of them, and two, I cheat the hydrogen with a 1.01. So as long as you're within decimal points, you'll be fine. If you're off by whole numbers, then we need to figure out what you've done. So again, don't hesitate to get a hold of me. You can either come to a student hour or make an appointment for an office hour where you can get one-on-one tutoring, or hit up the tutoring center, whichever you need. But you don't want to fall behind on this stuff. These again are going to be building blocks that we're going to see right away we're going to be using. So because what are we going to do with these? Well, you're not just going to calculate molar masses. We're now going to take this and apply it to what we were doing before. So if you recall, we were taking moles, turning that into mass for an element, and then taking mass and turning that into moles, moles to particles, and particles to moles. And then we even did a couple of problems where we figured out how many particles were in a set mass and how much mass was in a set number of particles. And so now we're going to do the same thing, but for compounds. So we're going to take advantage of this molar mass. So the molar mass then, just to remind you, is the number of grams in 1 mole of atoms, ions, or molecules. Now we're going to make conversion factors out of those, right? So we're going to take the molar mass. Remember, the molar mass is grams per mole from the periodic table. So to change grams of a compound to moles of a compound. So your question is going to change up a little bit. It's going to look like this. How many moles is 5.69 grams of sodium hydroxide? Now we've already seen examples where we did simply sodium. Now we're going to do a compound. We're going to set it up the same way though. So we're going to have 5.69 grams, and then I want to get rid of grams. So I'm going to put grams in the bottom, and I want to get into moles. So I'll put mole on top. Now the difference will be, I'm not just going to go to my periodic table and pull a single number. Now I'm going to have to pull numbers for each of the elements in the compound. So those molar masses we were just doing, we'll do the same thing here. So we'll look up sodium. Sodium's 22.99. Oxygen is 16.00, and again I'll cheat that hydrogen at 1.01. When I sum those up, I get 40, and that's 40 grams per mole. So now I'll simply put 40 grams in the bottom, 1 mole on top, and now I'll let the math go. And so 5.69 grams divided by 40 grams gives me 0.14225. And now I'm going to use my significant figures. I get 3 of them from the 5.69, and so my final answer then will be 0.142 moles. Now I know it always looks easy when I do it, so you might want to pause it here, go back, see this a couple of times to see how I put it together, and then go on to the next slide where we're going to start doing these problems. So how many moles is 4.56 grams of CO2? So I'm going to take 4.56 grams of CO2. I want to convert that to moles. So I'm going to make my bracket. I know for every 1 mole, it's going to be, and here's where we're going to do the molar mass. So I'm going to get my periodic table out. Carbon is 12.01. Oxygen is 16. I've got 2 of them, so that's going to be 32. I sum those up, and I get 44.01 grams. Now I'm going to take the 4.56, divide that by the 44.01, and I get 0.104 with sig figs, and that's going to be moles of CO2. All right, so hopefully you're able to follow along with that. Don't worry, if not, I've got a couple more problems for us to work on here. So, how many grams is 9.87 moles of H2O? So we'll start with the 9.87 moles. Of H2O. I'll set up my brackets again because it's just like conversion factors. I've been doing this the same way all semester. Hopefully you're taking advantage of that or using a different technique. All right, I want to get rid of moles. So for every 1 mole, now water, H2O is going to have a mass. Again, I'll use 1.01 for my hydrogens. There's 2 of them. I'll add 16 for the 1 oxygen, and I'm going to get 18.02 grams. I'll multiply that by the 9.87. I get 3 significant figures, and so my final answer will be 178 grams. All right. Again, don't forget you can always pause this and rewind it. It is a video, so you can do this over and over and over again until you're getting the hang of it. I'm going to go ahead and throw our last 2 problems up here. They're both 2-steppers, and so go ahead and give those a try. If you need, pause here, try it on your own, see how you do. Then start play, and you can see how I'm going to work the problem out. So for this number 3 here, we have 6.8 grams of CH4. We want to figure out molecules. So that's going to be 2 steps again. So I'm going to make my brackets. It looks like my internet is slowing down again. It was doing so good there for a while. This time I want to go to molecules, but I can't go direct, right? Hence it's 2 steps. The first thing I'm going to do is convert that to moles. So we're going to go mass to mole first. We've already actually worked this problem out, so you can always go back a few slides and check that out. But when we did this, we took carbon at 12.01. We added 4 hydrogens to it at 4.04 for the total. We summed that to get 16.05 grams. All right, now that would give me moles if I stop there, but we want molecules. So now I'm going to use Avogadro's number. And for every 1 mole, I'm going to get 6.02 times 10 to the 23. That is supposed to be a 23 up here. It's just really starting to lag down. I'm not sure why. All right, so I'm going to take 6.8. I'm going to divide that by 16.05. Then I'm going to multiply that by 6.02. And that's going to give me 2.55 times 10 to the 23rd. And of course, I can't leave it this way. I have to correct my sig figs here. So this is going to be 2.6 times 10 to the 23rd molecules. All right. So we see grams cancel out, moles cancel out. And then Avogadro's number, of course, in this case would be molecules. All right. I'm going to go ahead and erase that to try that last problem. So now we're going to take 49 molecules of that glucose. Just going to put big G here. We want to know how much it's going to weigh. So we're going to go from particles to mass. All right, so the first thing we're going to do is get into moles. And so for every 1 mole of glucose, it's going to be 6.02 times 10 to the 23rd molecules. And of course we want mass, so that's going to be 1 mole is going to be 180.18 grams. All right. So now I'm going to take 49, divide it by 6.02, then multiply that by 180.18. That gives me 1,466 times 10 to the negative 23. Remember, Avogadro's number was in the denominator, so that's going to be 10 to the 0 minus 23, so that's how I got the negative 23. And this, of course, will be grams. And we can't leave it this way. We've got to put this in the correct scientific notation. And so we're going to move that decimal point over 3 times. We're also going to apply 3 sig figs from our Avogadro's number. The 49 molecules would be a count, and so that would be an exact number. But this one is going to be the one that's going to generate our sig figs. So we only get 3, so that means this is going to equal 1.47 times 10 to the negative, and we moved over 3 times here, 1, 2, 3. So this is going to be negative 20 grams. All right, so these last couple segments have had a lot of math in them, so they've been kind of long. But that's going to end this segment for calculations using moles. If you're in Chem 100, this is the last segment for you. So just keep working at these mole calculations. Unfortunately, if you're in 110, we're now going to turn around and apply all of this stuff to reactions, as we're going to be looking at stoichiometry. So again, if you're in 100, this would be your last segment. And if you're in 110, you do have a couple more segments left in this chapter that you have to be able to work your way through. So if you're in 100, good luck. Best of luck on the exam. I'm sure there'll be an assessment following the mole calculations. If you need any help with any of this, and this is for both groups, basic or general, again, make sure you get a hold of me. The best way to get good at these things is to keep practicing, practicing, and practicing some more. So hopefully you're getting the hang of it, but again, just keep practicing. Talk to you soon.